Hello everyone, in this presentation we are looking at the basic operation on matrices. Last time we have learned what is matrix is, why we using matrix itself, and what is the dimension of matrix. Just quick summary, we are using matrices to storing data, information. This data become number in the linear algebra context, and the dimension of a matrix can be shown in this way. For example, that's a 2 by 2 matrix. 2 by 2 means that the first one 2 is rows, number of rows, and the second one is number of columns. So for simplicity, I am going to use a 2 by 2 matrix throughout this presentation, so be careful and listen carefully about this basic operation, because in the exam you can be confused sometimes what you need to do, and because of that you can get lost most of points in your exams as well. Okay, the scalar and matrix addition and multiplication is really simple one. The third one is really base and fundamental but really important, and we are going to use it pretty extensively. Okay, let's start it before wasting any more time. The scalar multiplication is, you have a matrix A. I am showing the matrices with A. More formal notation become this 2 by 2, or this showing that A is a matrix. A is a matrix. Okay, anyway, the scalar multiplication means that we have a number alpha which is constant. We have a matrix A, and this is equivalent to A times alpha as well. The reason I am showing that alpha times A equivalent to A times alpha is sometimes this is not going to be true. The third one we will show that is not going to be true as well. Okay, let's make a simple example. I am going to multiply with 2. We have an 1, 2, 3, 4, and result is a matrix as well. This is a 2 by 2 matrix. Always write the dimension. Do not forget the dimension. Okay, and we are going to 2, 4, 6, and 8. As you can see, what I did is I multiplied every cell of a matrix with the number 2 itself. Okay, that's it. That's this simple. Okay, the second one is matrix addition and subtraction. To do that, we have a certain condition. What is our condition? Condition is the matrix dimension which you are going to add or subtract have to be same. So matrix dimensions should be same. So this means that you have 2 by 2 matrix, and you can add or subtract with 2 by 2 matrix. So you cannot make an addition with 2 by 2 matrix and 3 by 3 matrix. The thing is become an important when we have an addition with number. For example, we have a 2 by 2 matrix. Let me write it this way, and we are going to write 2. Okay, how we are going to make this addition? Actually, there's a hidden matrix in here. We are calling this an identity matrix, and the identity matrix is a matrix which has 1, 0, 0, 1 in cells. This is the identity matrix for 2 by 2. For side note, let me write it that side note. For 3 by 3 identity matrix means that we have 1, 0, 0, 0, 1, 0, 0, 0, 1. You can see the pattern. The pattern is you have 1 on the diagonal part. We are calling this a diagonal part, and the rest of them become 0. Okay, this is a 3 by 3 diagonal matrix. Okay, we know how to multiply a matrix with a scalar number, so that this become, we have 1, 2, 3, 4 plus with 2. And what is the identity matrix of 2 by 2? The reason we are choosing 2 by 2 because we can make an addition with 2 by 2 matrix with a 2 by 2 matrix. Okay, so we cannot choose a 3 by 2 identity matrix because we cannot make an addition. This is our certain condition. Okay, this is 1, 0, 0, 1. We say that, and in this part we get that 1, 2, 3, 4 plus 2. 0 times 2 is 0, 0 times 2 is 0, 2 times 1 is 1. So at the end what we got is, watch it carefully, I am making addition of first cell with the first cell of second matrix, but I made a huge mistake. What is it? I didn't write the dimension of matrices. I mean, this is really important because sometimes we can forget it in our sequence of equations, and this can cause really crucial mistakes in our calculation. Anyway, I made addition 1 to 1, okay? And then for the second cell, 2 plus 0, this is the second cell. For the third cell, I am making the addition of 3 plus 0. For the fourth cell, I am making addition of 4 plus 2, okay? And this is result in 3, 2, 2, 6. So the thing is that for making addition or subtraction, we have one condition. You have a 2 by 2 matrix, for example, you can make an addition with 2 by 2 matrix. If you have 3 by 3 matrix, you can make addition or subtraction with 3 by 3 matrix. What about, there's a certain additional condition we also mentioned in here. What if I want and made an addition with a matrix and number, or made subtraction without number? We had a hidden number, hidden matrix, not a number, sorry. Hidden matrix, it's a called identity matrix. You can think it as a 1 when we have a scalar number, but in the matrix world, there's an identity matrix used for 1 in our basic algebraic operation, okay? Then we make a scalar multiplication with this identity matrix, then make the addition. Okay, the result is this. The third one is the most important one, but I am not going to show it up because we covered a lot. So for the next presentation, I am going to cover the matrix multiplication and dot product. So for the headlines, just to be sure we understand all the topic, the scalar multiplication, for the scalar multiplication, just multiply each cell with corresponding number, okay? So addition and subtraction, be careful about that. There's the one condition: you can add the matrices which are in same dimension, okay? And there's a special condition we also covered in this presentation. If you want to make addition or subtraction with number, multiply the number with identity matrix, then apply the operation for each cell. I hope everything is right now is clear. If you have any question, write in the comment section. See you in the next presentation where we are going to cover the matrix multiplication and dot product.